Hi, it's Mr. Srikanth Palan here, and in this video we're going to look at how to collect like terms, which is similar to what we looked at in a previous video, but this is going to have slightly more complex terms in it. Again, in this video you're going to need some confidence in adding and subtracting positive and negative numbers. So a quick recap of what you should already know before attempting this video. Have a go at this question, pause the video, and I'll go through it in a moment. Okay, hopefully you've had an opportunity to attempt that question. So if you remember, I would put different shapes around the like terms, including the coefficients. So I've done that with the x's with rectangles. I'll do that with circles for the y's, and I'll put a 1 in here. And I'll do triangles around the z terms. And then I'll simplify each shape one by one. The rectangles are 2x, add 7x. The circles are 5y, positive 5y, add 1y. And the triangles are positive, oh, I've missed a 1 there, should be 1z, add 3z. And that gives me 9x, 6y, and 4z. So 9x, add 6y, add 4z. Now, that is all covered in the previous video, and it's Tegerty task 156. So if you want to practice that before you go on with this video, then feel free to, because really you need to be confident with that before you can access the next bit. The next part is going to include expressions like this, in which you can see that there are these terms here that have squared in them, and we'll get into more complicated ones than that as well during this video. So before you attempt this video and the following task, first make sure that you're okay with task 156. Now I'm just going to do this for you so that you can see how this works. I've already highlighted the two terms that have an index in them, so I'll do the same as I did before for the other terms. There's a 1x there. And we haven't done any which have just a number term previously, but there's no difference there. And so I'm going to have three little parts to this. There's going to be the highlighted parts, the rectangles, and the circles. The highlighted parts are 1x squared, add 2x squared, which is 3x squared. The rectangles are positive 5x, add 1x, which is 6x. And the circles are positive 2, add 9, which is positive 11. And so my answer would be 3x squared, add 6x, add 11. But let's do that more slowly in a few examples. So here are a couple of questions. I'm going to do these as an I do, so you don't have to pause the video, but if you'd like to have an attempt before I go through them, feel free to. If you have paused it, then unpause now and I'll go through them. So first of all, we've got 3a squareds all being added together, which is just 3a squared. For the second one, we've got some cube terms and some squared terms and some without an index. And I'm going to pop a 1 in here and a 1 in here, and then I'm going to do exactly the same as I've done in task 156, which is to find things that are the same, the like terms, and put the same shape around the like terms. And so we get, in the rectangles, 1a cubed, add 3a cubed. In the circles, 2a squared, add 4a squared. And in the triangles, 1a, add 9a. So this is going to give us 4a cubed, 6a squared, and 10a. So my final answer is 4a cubed, add 6a squared, add 10a. Okay, on to an example that you can try yourself. So, worked example 1, pause the video and have a go at this question. Don't worry if you get it wrong, I'll go through it in just a moment. Okay, hopefully you've had an attempt at that question. I will go through this now. We need to be careful in this question. There are some things here to catch us out. First of all, there's no other terms with p squared in there, so this 1p squared is going to be the only p squared term. The next thing I'm going to look at is the q squared, so I'll circle those. And I've got some over here. Then I'm going to look at the things that have got PQ in them. The triangles are a bit awkward, so I'm going to change my colour here. And I'll do a red rectangle. I've got 5PQ there and negative 1PQ there. And I've also got numbers on their own, so I'll do that in a red circle. So I've got blue rectangles, blue circles, red rectangles, and red circles. Okay, so in the blue rectangles we had 1p squared. In the blue circles we had 1q squared, add 3q squared. In the red rectangles we had positive 5pq, subtract 1pq. And in the red circle we had negative 7. So I'll do the top and the bottom ones first because they're really straightforward. Don't forget that when you're finally simplifying something, and that is the question here, to simplify, we must write things as simply as possible. And in this case, p squared is more simple than 1p squared. So we can have this 1 that I've written in here, or here, or here. Can have that for working out, but not in a final answer. In a final answer, I need to get rid of those 1s. The bottom one is negative 7, that's not going to change. And then these middle two, I've got 1q squared add 3q squared, that's 4q squared. And 5pq subtract 1pq is 4pq. So my answer would be p squared add 4q squared add 4pq subtract 7. And I'm done. Okay, on to worked example 2. Bit trickier this time, it's question in context. The question is asked for the perimeter of the rectangle written as an algebraic expression. So pause the video and have a go. Don't forget you might need to remember what perimeter is. Okay, so I'm sure you remembered that perimeter is the distance around the outside of the shape. So that means that we need to add up all of the lengths that we can see. And the question's been quite helpful here because they've labelled all 4 lengths, when if you know it's a rectangle, it would have been perfectly reasonable for them to only give us 2 of the lengths, like this, and ask exactly the same question, and they would expect you to know that because this top length is 4x, this bottom length would have to be the same, because in a rectangle, opposite lengths are equal, and the same over on that side. But they've been helpful here, they've included all of the lengths, so we should be able to just write all this down. We need to add up the 2 4x's, as well as the other 2 sides. So, if we need to write that in a simpler way, we need to simplify this expression. So this is the perimeter, and the perimeter can be simplified because I can see that I've got some like terms, and I'm putting all of the terms that have an x in them in rectangles, and then that leaves me with a couple of things that don't have x that I'll put in circles. So then I've got to deal with the blue rectangles and the blue circle, which gives me 4x, add 4x, subtract 2x, subtract 2x, and positive 5, add 5. So that gives me 4x add 4x is 8x, 8x subtract 2x is 6x, and 6x subtract 2x is 4x. And at the bottom there I've got positive 5 add 5, which is 10. So my final answer is 4x add 10. Okay, worked example 3. So they want me to simplify some expressions here and find which of them, if any, there might be that none of them are, Which of them, if any, are equivalent to x subtract 2? Now, the easiest way to do this is to just simplify each one by one and check whether it comes to x subtract 2. So pause the video and have a go at this question. Okay, hopefully you've attempted that question. You probably want to give yourself enough space to work these questions out, so I'm going to split these over the next 3 pages. So the first one, x squared subtract 6x, subtract 1, subtract x squared, add 7x, add 3. So we'll go through the same process as usual. I'll use rectangles first. In fact, before I do that, let's pop a 1 here. And we can pop a 1 here as well. And then I'll put circles around these and triangles around these. And then I'll do the 3 shapes. The rectangles give me 1x squared subtract 1x squared. The circles give me negative 6x add 7x. And the triangles give me negative 1 add 3. So this is 0. 1x squared subtract 1x squared is 0. Negative 6x add 7x, that's 1x. Simplest way to write that, of course, is just x. And negative 1 add 3 is 2, positive 2. So I would simplify that by writing 0 add x add 2. Don't forget, though, that if I add 0 to something, that's what this says here, add 0. If I'm adding 0 to something, it doesn't change, so I don't need that. So my answer is x add 2. X add 2 is not the same as x subtract 2, so this one does not work. Okay, what about the next one? So again, I'll go through the same process. Pop some 1s in where they help me. And then I'll use rectangles for the first bit. Circles for the ones without a squared in them. Triangle for the number at the end. And then I'll look at each bit one by one. I've got 1x squared subtract 1x squared.